Hey, what's up, guys? This is Chung here again. So today, let's take a look at today's daily challenge problem, number 845, longest mountain in array. So you call a subarray a mountain if the following properties hold. First thing is if the length of the array is greater than 3, equal greater than 3, and there's like strictly increasing side and there's like strict decreasing side. Right? So, which means that, if you have something like this, increasing and then you go flat and then you go down, this is not a mountain, right? Same thing for this one, this one. This is also a not mountain, right? Which means that you have to have like a peak somewhere, right? So that's that. And I ask you to find the longest mountain, the biggest mountain. For example, if we have something like this, right, and then okay, this, and then this, right? So as you guys can see here, so this is a mountain here. This is not a mountain, and this is also a mountain, right? So so for this problem, there's really no fancy solutions here. So basically, we just loop through the entire array here, and we just need to find the starting point of a mountain and the ending point of the not the ending point, right? So I mean, we just need to find the starting point. So in this case, I'm going to use a left to mark the starting point for each mountain. So for this one, it's like the 0, and for this mountain here, I mean, is basically every time when we see an increasing sequence, we mark that as a base, right? We mark that as a base, and here we have a base, and then for the ending point, right? How can we do ending point? I mean, we start calculating the length of the mountains whenever we see a decreasing a decreasing sequence, right? But so for this one, it's not a decreasing sequence, as you guys can see. So once we reach here, that we didn't see a decreased sequence. Instead, we saw like a flat, right? So for that one, I'm going to, so we have a left and then we have another right. So whenever we have left here, I'm going to have a right here. So the right pointer will keep scanning forward until we find the ending point of this increasing sequence. And here, if we didn't find a, a decreasing sequence here, I'm going to move the left pointer up to here, and then it will try to scan it, but it will try to find the next increasing sequence, the starting point of next increasing sequence, which is something like, so the left pointer will go here, here, and then it will start from here again, right? And then the right pointer will keep going up, and then you find another one. Okay, so whenever it finds us a decreasing sequence here, every time when we find another decreasing sequence, it will just update the final answer until it has reached the ending point of the decreasing sequence, and then we move the left pointer to here again. That's how we calculate the mountains, right? All right, cool. So I mean, the implementation is really it's pretty short and pretty straightforward. I'll try to do it real quick here. So like I said, I have a base, I have a left equals to 0, and of course the answer, right? So while left is smaller than the end, of course we need that, right? And the first thing is what? So we find the starting point of increasing sequence, right? We find the starting point of the increasing sequence so that it could be a potential mountain for us, right? So either like this or like this. Basically, we're trying to find this location because that's going to be our starting point, right? So how do we find that? We simply use a while loop, right? While left is smaller than the n minus 1. So yn minus 1 because we'll be comparing with the next value here. And a dot left is equal or greater than the a dot left plus 1, right? So if it's not increasing, right, we just keep moving forward. We move the left pointer forward. And now, after this while loop, now the left sits on the starting point of the increasing sequence, right? And now we just need to move the right pointer. Now move the right pointer. So where is the right pointer? We initialize the right pointer with the left plus 1, right? So why is that? Because the mountain at least needs to have three length. That's why right has to be starting from the 1 to 1, right? So this is a mountain. This is our left here, and the right pointer has to be starting from here, right? It doesn't make sense to start from here, from the left itself. So now we have right. Now we just need to find the end of increasing sequence, right? We we move the right pointer to n minus, and a right is smaller than the a dot right plus 1, right plus 1. So at this point, right, so now the right is at the end of this increasing sequence, right? So again, so we have a left here, we have a left here. Now the right is here, right? Because we use this while loop. So the right, so now we have there are like two options, the two possibilities here, right? So it could be like this, or it could go down. So how can we handle these two possibilities, right? I mean, not we simply try to find the what, the decreasing sequence, right? Trying to find the decreasing sequence here, starting from here, which means that if while right is smaller than the n minus 1, right, and a dot right is it's greater than the a dot right plus 1, right? So this is like the decreasing sequence. If it has a decreasing sequence, then we know, okay, we find like a mountain, right? So the right, we have to do right plus 1 first, and then we update the answer, right? Max dot answer dot minus left plus 1. So keep in mind here, no, be careful here. So we update the right first, and then we update plus 1. Why is that? Because at the current location, the right plus 1, that's the next decreasing sequence low position, right? So not the right. It has to be the right plus 1. That's why we do a right plus 1 first, and then we update this answer here. And then while this while loop when this while loop is finished, then we know, okay, we have reached the end, which means that it's either the starting point of this, right? So when this while loop finishes, these are like the two scenarios. So we have a left here, and then the right could be here. If there's a like a plateau on the top here, so basically we'll never go into this while loop. And here we have so the right pointer is right here. The right pointer is at this location, right? And another case is like this. Another scenario is we did find a real mountain, and this is like this. And another scenario is like this. So the right pointer is somewhere, is right here. And then here it could be either going up or go to the left, but it doesn't bother us because we have find the answers, and all we need to do is we just need to update the left equals to the right, and then we'll leave the rest to the next while loop to handle us, because once this while loop is finished and we update the left pointer, these things the first while loop will help us to find the next starting point of the increasing sequence, either the same location right here, or it has to be going forward until it finds the next sequence, the increasing sequence, right? And then in the end, we simply return the answer. All right, I think that's should do it. Let's try to run the code here. All right, so submit. Cool. So accepted. Yeah, and as you guys can see here, it's just a one pass, right? One pass traverse, and it's all off. And well, actually, there's a follow up here, right? So it's even asks us, can you solve this one using only one pass, and can you solve it in O1 space? Well, actually, we have met all the conditions here, right? There's a one pass and there's only a O1 space. Yeah, actually, I'm kind of curious, like what the I think there could be some two pass or even three pass solutions. Probably for the first pass, you find all the peak, right? Find all the peak, and then from the second pass scan, you find the starting point and ending point, something like that. That's why I mean there's a follow up, right? Well, actually, I'm kind of curious if I can find those. How can we solve this problem in two pass? Anyway, I'll stop here. Okay, thank you so much for you guys to watch this video and stay tuned. I'll be seeing you guys soon. Bye bye.